Delherbe. I'm a PhD student at the Nati lab at San Diego State University. And today I will present our work about the reverse methane chimney effect. So the life in our planet is possible among many things because we have an atmosphere, which is a mixture of gases that protects us from the radiation of sun and also provide the gases that we need to survive. So the radiation of sun comes and hit the surface of the Earth, but the excess of heat can go back to space, having a suitable temperature for our life. However, because we are experiencing now a climate change, because of the increase of greenhouse gases in this atmosphere, what is happening is that the radiation of the sun comes here and the excess of heat cannot be released back to space. So this is not happening and the temperatures are rising up. So in our laboratory, what we are doing is focusing on one particular greenhouse gas, and this one is methane. So methane is important because it has a warming capability of the planet that is about 80 times higher than the other common greenhouse gas, that is CO2, that it only has the potential of 1. So I'm trying to understand how we can reduce the amount of methane in the atmosphere. So methane can come from different sources. They can come naturally from the decay of organic matter in the environment, but also it comes from human activities. Between these human activities, we have the livestock production. So each burger that you consume has an impact on the amount of methane that we have in our atmosphere. There is also production of methane from the agricultural activities as well, because there is an excess of organic matter in the soil, and then the plants can release the methane to the atmosphere. And ultimately, we have an input to the atmosphere coming from industrial activities. So the release of coal and other energetic sources release also methane to the atmosphere. So in our laboratory, we are focusing in one of these particular activities, and this one is agriculture. And we're focusing on that one because we are studying what is happening underground of these plants. So where we have the roots, the soil surrounding this root has a lot of microorganisms, including bacteria, archaea, viruses, and other eukaryotes. And within the big diversity of microorganisms that inhabit the soil surrounding the roots of the plants, there is a particular community of them that they are called methanotrophs. And methanotrophic bacteria are bacteria that are able to consume methane. They eat methane for survival. So they needed to produce their own energy and to build up their biomass. So we are using these organisms to help to consume the methane from the atmosphere through using the normal capabilities of the plant. When they are consuming the gases to obtain the CO2 from the atmosphere to do the photosynthesis process, they are also capturing methane because it's also in the air. So they are passing it through their system down to the roots where the methanotrophic bacteria and another bacteria are inhabiting, and then they making more available for them for consumption. So this process is the one that we call the reverse chimney effect, because as you can see here, as this chimney illustrates, the smoke comes from the inside to the outside and is released to the atmosphere. But what happens often is that also the plants can do that when the organic matter is high, and they also release methane. But if we can figure out the ideal conditions, for example, watering, and how much organic matter is in the soil, we can manage to increase these communities that are beneficial and that they are able to consume the methane. And then we can use this capability of capturing the methane and trapping it in the soil for removing it from the atmosphere. Thank you very much. Stop? Good. Yeah. What?